We're going to talk about today. Pick back up from Saturday. If you remember on Saturday, we talked about how to find the area underneath a curve. Okay? Well, today what we're going to do is we're going to find the area between two curves. Okay? So,
Between two curves?
area between two or more curves. Okay? So basically, we're doing the same thing we did before, except instead of doing it for just one curve, where we're doing the area between the function and the x-axis, we're going to do it between two functions instead. Okay? And figure out the area behind. So an example, something like this, of a system like this, might be area between f of x equals 4 and g of x equals x squared. Okay? What do you think I'm going to do if I had to figure out such an area, such a system? I would do what?
Graph.
Graph first. Okay, so let's graph the system out. Okay? What does fx equals 4 look like?
Steep
Well, it's going to be straight.
Straight line going through 4, right? So that's it right there. This is f of x equaling 4. And what does g of x equaling x squared look like? It's a parabola, right? So the area we want is this stuff in between the two, okay, is what we're after here, okay? And that's what we want to get, all right? Now, how do you think I could find that?
Subtraction and addition.
Okay, subtraction, addition, but how?
Treat that as the x-axis. What this treat the f of x equals 4 as the x-axis.
Okay, and then move x squared down 4 spaces
Yeah.
and treat it that way? That's an interesting way of doing things, and actually, that would actually work rather nicely in this case.
Use the areas.
However, okay, that would work great for this particular problem, but it wouldn't work for other problems, okay? It works great for here because f of x is equal to just a straight line. But I like where you're going with that. That's a good idea. Hold on to that idea. Yeah.
You calculate the area, you do f of, or you do the distance between the left side of g of x and the right side, so you get the area underneath the curve, and then you subtract that from the total square area.
Okay, so you're saying basically you find the area of, are you saying you would find the area of this
that
right
whole
here
thing,
in
yeah.
blue?
And then you would
And then subtract the area underneath x squared where these little, and then subtract these from it?
Yeah.
Ah!
Or at least
And that
that's
would
what
give
I'm
you the
guessing.
area?
That would
Would
give you
that
the
always
area
work, though?
between the two functions.
It absolutely would, wouldn't it?
Would that always work?
It would always work, wouldn't it?
Yeah.
That's exactly what you do. Okay? Basically, that's how we treat this. So, how you find the area between two or more curves, okay, is basically how it works is that if f of x is greater than or equal to g of x, okay, on an interval from a to b, okay, then the area between f of x and g of x is equal to the integral from a to b of f of x minus g of x dx. That is, you find the area of f of x and then subtract from it the area from g of x. Okay? Again, remembering that these areas are the stuff bound by the curve in the x-axis. Okay? So, in this case right here, all we would need to figure out is what a and b are. Where is f of x greater than g of x in this system? Where does that happen? Where they cross, right? Where do they cross at?
4.
Not 4. F of x equals 4. So x squared needs to be equal to 4. So what?
2.
2. And negative 2. So these locations here are x equals negative 2 and x equals 2. So those are my A and B. So the actual area of this thing then, of the area of the green region, is going to be the integral from negative 2 to 2 of 4 minus x squared dx. And that you can calculate by hand. You could also do it this way as one integral, or if you'd rather, you could break it into 2. You could make it the integral, so I could write here, or the integral from negative 2 to 2 of 4 dx minus the integral from negative 2 to 2 of x squared dx. It won't change at all how the answer comes out.
I know
Okay.
which one's A, which one's B.
For the numbers, you always go from least number to bigger number.
Okay.
So it's always from, so yeah, the A is always supposed to be less than B in these problems. If you flip them something, all it means is that you flip your answer. Your sign would be negative at the end instead of positive. Okay. I'm sorry? What's the what? What mark? This thing right here? That's a straight mark. That means nothing. It means nothing.
And so you flip the signs of the.
Oh, so he's saying, well, how do I know if which one's A and which one's B? A is always less than B. You always go from a smaller number to a bigger number. But if for some reason he wrote 2 down here and minus 2 up there, all that would happen is your answer would have the wrong sign. It'd be the same numerical answer, you just have a negative in front of it instead of positive, or vice versa. Okay. In this case, it'd be a negative because we're looking for an area, which we know should be positive. So,
So
Okay.
basically subtracting, isn't that integral just the area underneath the curve anyway?
that's exactly what it is. So we're subtracting the area of one curve from the other. Okay? So basically, to find the area between the two curves, we're finding all the area underneath f of x, and then subtracting the extra area that's found by g of x. Okay? So the yellow is what we're getting rid of there. Okay? That gives us
example of 2 curves.
2 curves. Yeah, we'll do it with 2 different ones. I mean, instead of doing it with f of x, which I know is a flat line, we'll do it with a different one. In fact, we'll do one that we'll do a problem that will guarantee you will be on the AP exam. Okay? Non-calculator part of the AP exam will always have this problem on. Okay? Everyone got this down? Yeah. Oops. Yay.
So is that blue area technically going to be a square?
In this case, a rectangle, but yeah.
But isn't f of x equal to 4? So it'd be 4.
Oh, I guess it's 4 by 4, so yeah, it would be a square.
So,
I guess. Well, square is a rectangle, so I was right before.
yeah.
But yes, it is in this case, because it's just a flat line.
Or is it a rectangle?
So you don't need to actually find
No,
the area.
square is
of
rectangle, rectangle is not square.
I'm sorry?
You don't actually need to find the area of the blue.
Well, you do,
It's just
but I mean,
that's
it's
the
gonna be 16.
definite.
Yeah. And if you did it, notice the definite interval there will be, it'd be 4x evaluated at 2 minus 4x evaluated at negative 2. So it'd be 8 minus minus 8, which is 16. Okay. Which is indeed correct, yeah. So
it's the yellow part that we're looking for?
no. It's the green part that we're looking for. The yellow part's the extra area that we're going to get rid of. Okay. To find that. Basically, the yellow part is the area of this. So if I came through here, this was the blue part, this was the yellow part, and whatever this thing is equal to is our green part. Okay? Up there. Alright?
How would you do more than 2?
Okay, let me show you. Yeah, let's do another example or two of these, okay? It's all about figuring out which function is above which other function. It's the next one we do, we're going to do it where, again, we're going to do this particular problem that's always in the AP, but it's also not a straight line. It is a straight line, but it's a diagonal line and a curve, okay? So let's look at that one next, okay? So our next example here, because we'll always see, okay, this is an AP problem directly, is find the area bound between f of x equals x and g of x equals x squared, okay? So stuff that's specifically between those two, okay? Now, first thing I'm going to do, as always, I want to draw my system out. What does this look like? F of x
Straight line.
is a diagonal line like so. G of x is a parabola. It starts off less than f of x, then crosses and becomes greater than f of x, okay? So they cross at the point 1, 1, and at the point 0, 0. So what this problem is asking us to find is this area in between, okay? We want this stuff right in here, okay? That's what it's asking for, okay? So, okay, we end up setting this one up as the integral from 0 to 1 of x minus x squared dx. So what's that integral going to be equal to? What's the integral of x?
X squared over 2.
X squared over 2. Integral of x squared?
X squared.
X cubed over 3 from 0 to 1. So that's going to give me 1 squared over 2 minus 1 cubed over 3 minus 0 squared over 2 minus 0 cubed over 3. Okay? So we work this out here, and it's going to be 1/2 minus 1/3, which is equal to 1/6. Okay?
So is that one on top, on the top integral? Is
Yep. Oh, so which one? Sorry.
A? Oh, okay, that's all.
That right there? That's the b. So it goes from a to b. So 0 to 1.
So does the 1 represent the x or like the y?
X.
The x?
Yeah. So the numbers you see here are always x coordinates. They're telling you where you started and where you stop in terms of x. Okay? So we started at 0 and we ended at 1. Okay?
And how would you say which one goes first? And like the
Always the one that's on top. That's why it's important to graph.
No, the f of x and g of x.
Yeah.
I didn't know which one goes first.
Again, it's the one that's on top. The one that's greater than the other. So that's why you always graph the system out. You see, from 0 to 1, I can see that x is always above f of x is always above g of x there, right?
Okay.
Now they flip, so if I asked you, if I went further and said, instead of from 0 to 1, set the stuff bound between the two curves from 0 to 2, afterwards they'd flip and I'd have a different integral. I'd have to calculate and just flip x and f of x and g of x.
Okay.
And that's in fact how we can get multiple curves involved here, okay? I could write this system out to say, I could draw a system out and say, find the area bound by these curves, and have the system with, have multiple curves come out, okay? So copy this one down and I'll write out a system based off of this that would look sort of what I talked about, okay?
That line with the 1 and the 0, that just means you're plugging in those points.
Yes. That's all that means. That line there is the notation for evaluate at 1, then subtract it from 0. Okay?
Was there?
So, what's in the bracket is big F of B
Yep.
minus big F of B.
Exactly. Definitely know this.
Yeah.
Okay. Now, where do you think these things can get really weird?
Multiple curves.
Multiple curves, but how else?
Like sine graphs.
Okay, where they dip below the x-axis, okay, or they oscillate, or things like that. Okay, there's a few other classic ones that we could do that usually appear on APs.
So that 1/6, that's the answer.
That's the answer. The area between the two is 1/6 units. Okay, squared.
So we have that formula that we use every time.
Yeah, basically it's the bigger function minus the little function. You're taking the definite interval.
And then you
Okay.
just use the.
Yep. Where this thing can get confusing is again if things dip beneath the x-axis, because then the rules change. Okay. In fact, if all these areas are beneath the x-axis, you can still do this. Just remember you're doing the absolute value of the answer. Okay. So that's one thing. But if they're like switch places, it can be a mess. That's why it's always want to graph it first. Okay. Everyone got this one example down? Alright, let's look at an example with multiple curves, okay? So basically, the directions here would be, in this case here, we'll have a drawing, okay? Oops, I don't want to use that. It's black. Black, that's so
So, yeah, 1/6 of the front area.
Uh-huh. Alright, so there we have it here, okay? We want to find the area, or find the shaded area between f of x equals x, g of x equals x squared, and h of x equal, one, we'll say two, we'll say 4, okay? Okay, so we want to find the shaded area between this. All right, how many intervals do you think I'll actually need here?
2.
Somebody said 2.
Three,
Why 3?
Just
because you're gonna do
Okay,
2
in this,
and comparing 2, or 1 with another 1 with another 1, 1 with another 1.
okay,
Is that a straight line?
that is supposed to be a straight line. That's supposed to be h of x equals 4. My drawing is terrible. So that's one thing you want to do here. Go ahead and identify each of these lines. There's my h of x. Here's my f of x right here. It's the horizontal, it's the diagonal line, and my g of x is the parabola. Okay, so those are my 3 curves. Now, you were correct in that it's going to be 3 intervals. How I want to do that when I approach a system like this, I want to go ahead and say, okay, what actual areas are there in question? Because it's the shaded region makes it look like there's just 2 areas, but in reality there's 3 different zones here. Okay, we've got zone 1 is pretty obvious. It's this junk right here. That's, we'll call that area 1. Okay. Then up here, notice if I drop a line straight down there, this area up here gets divided into 2. One part of it's g of x above h f of x. That's one area. We'll call that area 2. And then the third area is the stuff between h of x and f of x. We'll call that area 3. Okay. By the way, what I'm doing here, labeling out areas as 1, 2, 3, it's very useful to solving a question like this. Okay. You've got multiple zones in question. You got multiple zones here. You got to figure out when each zone starts and when each zone ends. Okay, things like that. So we've labeled out the 3 areas in question, so we can see exactly what we're figuring out, what our intervals should be. Our first one, area 1, what interval is going to be on top? Or what line is going to be on top? F of x. So area 1 here would be from A to B of f of x minus g of x. And what would the numbers be? We did this in the previous problem. It would be from
0 to 1.
0 to 1, okay? That's area 1. What's area 2 going to be?
From
X squared.
X squared minus x this time, right? But then from where to where? It's from
That
1, because that's where these things start right here, right?
4.
They start at 1, and then they end when g of x crosses h of x. So what's the x value at that point? Not 4. That's what h of x is equal to. So the y value is 4 there. So the x value has to be 2.
Wait, to
Okay.
find that you do x squared equals 4?
You do x squared equals 4, yes. Okay. So note here you're also adding in some stuff from pre-calculus where you're finding the intersection of 2 lines. Okay.
So how many minus 2 again?
Oh, right here at this location right here, Sutton, this is going to be the point something 4, okay?
Yeah.
We know that because that's what h of x is equal to there. H of x is 4. So we need to say, okay, when does x squared equal 4?
True.
When x is equal to 2, okay? And then our last interval, okay, our last area, area 3, is going to be equal to the area from 2 to where? Again, it's going to be when x is equal to this location right here. This has a 4. When does x equal 4? At 4. So this is the point 4, 4. Okay? And so we would end this point at 4. And which one's on top here?
H of x.
H of x. So it'd be 4 minus x dx. Okay? And now, you've got three intervals you have to figure out the area of. But at this point, it's fairly easy. Integrate that one, integrate that one, integrate that one, add up the rest of the answers, and that's the total area of the shaded region. You can use a calculator for that, by the way. Okay. Does everyone know how to use the calculator to find these integrals?
No.
Okay. Let me go over that again. Okay.
Oh, the graphing board?
Yeah, the graphing part. So each of these are easy enough to do by hand. So this is something you could possibly see as a non-calculator question, okay? Because none of these integrals are exactly rocket science here. They're not doing anything strange. But, I'll bring it back up in 1 second. Okay. But a lot of times these problems end up being ones that are calculator based.
You said rocket science, then went to man on the moon?
What about the man on the moon?
Rocket
It's,
science.
they're not rocket science, then you close the window.
Oh yeah, the man on the moon. I like that, yeah.
What's that TV show about those guys who have like rocket science degrees and they do all
Rocket
this,
power
Oh,
No, it's
Rocket
not.
City Redneck.
with
like,
auto.
yeah.
Oh yeah. Okay.
Is that still out?
No, I don't think it
It's on Netflix.
It's on Netflix?
Yeah.
Solid.
Okay.
Yeah.
But how this would work here, okay? We would just enter these integrals in exactly as they appear. So this first one, x minus x squared, I would graph that exactly as it reads, x minus x squared, here, where's the square?
How'd you
Above
figure
log.
out that's how you're gonna set up as x minus x squared?
How do I figure that out? Okay, I'll explain that in 1 second. Let me just finish this out, okay? We'll go ahead and graph this one. Now, the picture it's going to give me is not going to be the same as the picture on the board, okay? Because I'm entering the function x minus x squared, not f of x minus g of x. Does that make sense? So my graph here is not going to be the same here. Now, I could graph the system as it appears, and then do every integral as 2 separate integrals. That would take this from being just 3 integrals to making it 6, okay? Who wants to do 6 integrals? Okay, Diego does, but everyone else is wisely saying, Well, we know by theorem it's just the one minus the other, so we can set it up as one minus the other, okay?
Yeah.
In this case here, there's a small smidgen of this that's above the x-axis from 0 to 1. And I'm going to tell the calculator to find that for me by saying, second, calculate. My 7th option is the integral. It'll say for lower limit, that's the first number. Upper limit, that's the second number. It does its magic. And it gives me 1.666666667. That's 1/6. Okay? That's what that number is. We figured that out before. Okay? So we know that this answer here is 1/6. Okay?
Can you press fraction right now and it'll show you the fraction of that?
Oh,
You
Math,
want
like
second, right?
it's like math and then fraction or something.
Calculator.
Alright, there it goes.
Useful.
Yeah. Good stuff. Okay? For our next one, from 1 to 2,
Like 0.8 something.
Could you not?
sorry,
That's the way to find that.
The lower limit is 1.
0. Yeah, 0 first, then 1.
Let's make it count.
There you go. Okay. You're going to ask something, Chess?
If
Would you be able to put these in like y1, y2, y3, and like?
No, all 3?
Actually, I'm
You could, but when you do that, to figure out the integrals, you're going to have to do the integral of x, then minus the integral of x squared. So it won't do both at the same time. Does that make sense? It will only do one. It will only do one line, one integral at a time. Okay. Does that make sense? All right. So we're going from this one. For our second one, we're going from 1 to 2. So we hit second calc. Option number 7. Minimum is 1. Upper point is 2. Calculator does its jazz. And we get 0.83. .3 repeating, 0.83 repeating is what? It's like,
Fraction.
is it like, oh yeah, it's fraction.
That's 5/6.
5/6 is what it's. But he's got the better answer, just we can fraction it. See, I never knew the calculator, I mean, I knew calculators could do this, I just never bothered to play around with them enough to figure out exactly how to do that. Now I know, thank you. I'm gonna have to remember
So
this.
what
Can you do? How do you fraction
Just
it?
press
Apparently
math.
there's a button that says math,
Well, that does.
so it's right there. And the very first one says fraction, if you hit enter, it'll say answer fraction, and it gives it to you as your last answer as a fraction. Okay? So 5/6 there. So that area is 5/6. That's kind of neat. Okay? Then we're gonna do the same thing for this guy right here. Go in here, clear this one out, do 4 minus x. Although honestly, the integral of that is super easy. You should be able to do that with my hand, but whatever. Okay? Because it's this line right there. And we're doing it from 2 to 4. So it's a triangle actually. So lower limit's 2, upper limit's 4. Gives us that, and the area is 2 there. So if I add all these together, 1/6 plus 5/6 plus 2, what's the shaded region's area?
3.
3.
Ta-da! But that's how you would handle multiple curves, just like this, okay?
If, what would have happened if, like, see right there, the, on the calculator, if the shaded region had gone to like 6 and then had gone underneath, would that have given you, can you say that there's like a shaded region in the 0? Do you say that can happen sometimes?
Oh, that
Because like the area above and below.
and below cancel each other out. That is possible. However, when you do things the method I've done right here, that will never happen. You never have to worry about manually entering in these integrals and having one of them become negative. That's not going to happen here, unless this system itself had parts that dip beneath the x-axis. And then you account for that because whenever it goes in beneath the x-axis, you find the 0 and then cut your integral there. So the negative side is only the part that you count that's negative.
Do you not need an absolute
Okay.
value to find the area?
Which is what you would do there, yes, in that situation, okay? But I see what you're saying. That's not going to be a concern when doing this, okay? Unless the system itself goes, okay? Yes?
So you found the points, so like in the integral of the points, like 1 and 0
Uh-huh.
and A1, that's just from graphing and finding where they intersect?
Exactly. And that's also how I determine how to write these integrals out, Jim, is I looked to see which one, well, you asked this earlier, how do I know how to write these integrals? It's all a matter of which function was on top of which function when I at the zone. So by area 1 here, my first shaded region, f of x equaling x is above x squared. So that's why this integral is written as x minus x squared, okay? And how I know it's from 0 to 1, that's where they cross. They cross right here at 0, and they cross again right here at 1, 1. Yep. That's how I was able to write that one. My next one, they flip. X squared is bigger now, so it's first, so it's x squared minus x. And we end the system at 2 because that's where x squared crosses the line h of x. Okay? And so you're figuring out the intersections as well.
So how do we know like which one's x squared, or I mean how do we know, I guess, when we're in the parentheses, like how you said this one's above x squared?
Right.
How do you know? Like how are you telling that?
Look at the graph.
Yeah,
Okay? Right here. Okay? In this one right here, which is bigger? The straight line or the curved line that's underneath it? The curved line's underneath the straight line, right? So that's how I know the straight line's on top.
Oh,
So that's
okay.
why I write the straight line
Okay.
first. Okay? Yes.
And
Better
then
now?
straight line on the bottom on the.
Right, and now here they flip, and so from here to here, this little curved part is bigger than the straight line now, and that's why the answer flips. But then, when they hit this location right here, we don't care about the curved line anymore, it's just the two straight lines that form the triangle, okay? And that's how we figure things out. So you're actually physically looking which one is above the other one. That's why it's so important to graph these things first, okay? Because you need the picture to see what's going on, okay? Very much so. Now, in some cases it's obvious, okay? Like in my very first example we did up here, which I don't think we actually, did we actually solve this one? I don't think we did.
Yeah, we did.
Oh, we did, yeah.
Okay.
Okay, you know, it's fairly obvious here which is above which, okay? But in this one right here, or in this one right here, you really did want to graph them to see, because most people are like, well, x squared, something that's squared is usually bigger than something that's not squared. So a lot of people, when they do this problem, they don't graph it. They say it's x squared minus x. But between 0 and 1, that's not the case. X is bigger, okay? So you have to account for that, okay? And then here, you really had to graph it because we had 3 different curves in this case. We had to see what's going on in the system. Yes?
Well, how would you have graphed in your calculator the first problem?
This first one?
Yeah, would you just do?
I could
Y
do,
equals 4, y equals.
yeah, I could do
X
4
squared.
minus x squared directly in the calculator. Okay?
Okay.
So, again, you don't have to do the system as it appears by hand. Well, let me show you what I mean here. Okay? Come on.
Wait, so how is that x squared different from the x squared in the graph?
Hang on one second, guys. There we go. Okay. So, our first example here, okay?
Ooh.
The graph of the system, if I graph it as it appears, I do 4 over and then x squared like so, okay? And so that's a picture of what I just, of what's drawn up here, okay? As it draws it. Okay. There it goes. Alright. Now, I could, everybody, so here's the picture drawn with the calculator. Now from here, if I wanted to find the area from this system directly, I'd have to figure out I'd do the integral of everything beneath 4, then write down that answer and subtract it from it, the integral of everything beneath x squared, okay? Which is one way I could do it, but how many integrals did I do there? 2. I could, though, once I know what's above what, I could write this as one integral, okay, by doing what I did right here, writing the area as just one single equation. In which case, I can come through here and say 4 minus x squared, and that's going to give me another integral right there. There we have it, okay? And the region bound by it, that new equation I just wrote by doing the 2, that's the exact area, okay? So I could do that integral instead.
I
Okay.
got 10 2/3.
10 2/3? Sounds right, because it's 16 minus whatever is underneath x squared, which x cubed over 3, so it would be 16 thirds is what that area would be. So 16 minus 16 thirds.
What are we trying to calculate, like? if you
Okay,
had to
so
fill it in?
I added one more graph in here. Yeah, so
Why does that parabola?
this is our, oh, come on. Okay, so this was the original system right here.
Second half,
Okay.
it doesn't have to
Okay.
touch.
So this is me just graphing a picture of what's going on, okay?
So there's no point.
So we want the stuff that's this right here, okay?
Yeah.
Stuff in between the 2 curves. Well, I could do that as either 2 integrals. The integral from the stuff beneath the first curve, the straight line, and then figure out the stuff beneath the parabola and then subtract the answers. Or I can rewrite them both as a single integral by combining the 2 together, which is what I did right here. Okay? And then I'm finding whatever is bound between this curve and the x-axis.
Oh.
That's easy
Oh,
enough.
so you just flip it.
From 0 to 2. And that gives me the area exactly. It's not so much that I'm flipping it, it's just I'm setting up, basically I'm finding a function for this area. Okay?
But you could just do the integral of that, it would be the.
Yeah, and it gives you the answer directly. Okay?
Can you go to the other problem I gave with the 3?
Yeah.
please?
So,
So, why wouldn't you completely write out x squared and then do all the space between the x, y equals h of x equals 4?
so,
Because isn't the x squared a parabola like on the other one, and then the other side would go up too?
yeah. So, are you saying, how come I'm not doing just all of this area?
No, like the other half of the x squared.
What about the other half of the x squared? Like this little part right here.
No, like the other side of the
On
parabola.
the side of the parabola.
Yeah.
So when it comes over here.
And then where it intersects with h of x equals 4.
Oh, I didn't write out that part there. It's because that wasn't part of the original question. The original question here was not find the stuff bound by all three.
Oh, the shaded
It's
area.
find the stuff in the shaded region. Okay? And that's generally how these things will be described. Okay? Or it has to be the stuff bound by all three. If I go out that far, X no longer is part of that system, so we wouldn't want to use it. Okay?
Yeah, I get it.
But that's sort of how these things work out. Okay? Typically, they're either going to be a situation like this where find the shaded area between. So they'll shade a region and say find the area of this, like we did in this problem. Or they may give you something where you've got something like this right here, where I've got two straight lines crossing each other, and then a parabola beneath them all. And the shaded region in this question, they would say find the area bound by all three curves. It would be this region right here, okay? And I wouldn't count the other regions. It may only be the regions where clearly the stuff overlaps each other, okay? Usually when they say the word bound, they mean where there's actual boundaries. I'm not going to do anything alpha over here because they're technically unending.
How do
They
you
just
do
keep
that?
going and going and going and going, right?
Yeah.
Okay? They're never going to meet each other. Actually, they will cross eventually up there, but we're not interested in that.
What lines do you, or what equations do you use for that one? Do you-
Well, it'd be whatever these curves are.
I know,
So
but in what order?
I would do, let's see,
You can't pin that on me.
we'll call this one f of x, the parabola is f of x,
I don't think.
the downward curve is g of x, and the upward curve is h of x, is how I'm going to label them. It would be basically, well, this one gets really difficult. It would be h of x minus f of x from where the two cross right there, which we call A, to where f of x crosses the x-axis. Okay?
Okay.
We'll call that location B. Okay?
Okay.
Then you add to that the integral from h of x just by itself from that crossing location, which we call B, to where it crosses g of x. We'll call that location C. So A, B, C. Okay? Then we add to that the absolute value of,
So you have to do the three quadrants, or the four
well,
quadrants.
you're going to have a lot in this particular example here, because the way I drew the system.
Okay.
But that's how you would go through and label out each zone. We'll look at an example like this tomorrow, or I guess Wednesday. Okay?